This is the solution video for the first quiz on Chapter 15. So I'm just going to dive right in. The idea of this quiz was to see if you know the formulas yet and see if you can use the formulas. So the general addition rule is about or, so it's the probability of A or B, and that's going to be equal to the probability of A plus the probability of B minus the probability of A and B. Okay, so what we're saying is that if here's a picture, if we have A and B, then they overlap, and if we're going to add the probability of A and B, we can't count the middle twice. We have to subtract it off. We have to subtract it off once. Okay, so the general multiplication rule would be for A and B. Okay, and so that's going to equal the probability of A given B. No, excuse me. My bad. Thinking too far ahead. The probability of A times the probability of B given A. Or you could be the probability of B times the probability of A given B. Either way works. So here, for the general rule, we're sort of either assuming we don't know. We don't know if A and B are disjoint, so we have to subtract off this term. Same here, only with independence. We don't know if A and B are independent, so we have to have this conditional clause here. If they are independent, then this is simplified to just the probability of A times the probability of B. And over here, it'd be the probability of B times the probability of A. The condition doesn't matter. But it's easier just to know the general rule, and then you don't have to worry about it. Okay, so speaking of conditional probability, here's one. The probability of A given B. So the probability of A given B is equal to the probability of A and B, so the overlap, divided by the probability of B. B is the given in this case, so another way to think of it is the probability of both occurring divided by the probability of the given. Okay, sometimes this helps. Now, a test for disjoint. So two events are disjoint when there's no overlap. So this Venn diagram here represents a not disjoint. So what we'd like to know is maybe we just say if the probability of A and B equals 0, then A and B are disjoint. Otherwise, they're not disjoint. So if you can prove that they're not 0, it's not equal to 0, then they're not disjoint. Okay, what is a simple test for independence? Well, what we can say is we can say if the probability of A given B is equal to just the probability of A, then what we've shown is that the condition doesn't matter. So then we would say then A and B are independent. Otherwise, if not, if probability of A given B is not equal to the probability of A, okay, then A and B are not independent. Okay? Alright, so now let's try out these formulas. So the probability of A, so we're kind of being told the probability of A is equal to 0.34. The probability of B is equal to 0.27. And the probability of A and B is equal to 0.12. So for the Venn diagram, this is 0.12. And then A includes 0.12 and all the other stuff. So we have to subtract it off. We have to subtract 0.12 from 0.34. So we get 0.22. So this is 0.22. And then the same here, we have 0.27. So we have to subtract 1, 2. So we get 0.15. So this represents all the areas. So the last thing is the probability of neither. So we could add them up. 0.22 plus 0.12 plus 0.5. So if we add these up, we get 0.49. So 1 minus 0.49, so this would be 0.51. So a lot of people forgot to do this. It's important to do it. Okay, so what's the probability of A or B? So there's a couple ways of doing it. The probability of A or B from the diagram is 0.22 plus 0.12 plus 0.15, and that we've already done. It's 0.49. That's one way to do it. Another way to do it is to use the formula. The probability of A or B is equal to the probability of A plus the probability of B minus the probability of both A and B. So that's going to be, the probability of A is 0.34 plus 0.27, and then we need to subtract off 0.12. And again, it's going to be the same thing. It's going to be 0.49. Okay, so what's the probability of A and B? So the probability of A and B is available to us. It was given to us, and it's here on the diagram. 0.12. So it's real. That one's real straightforward. Just pops out. What's the probability of A? The probability of A given B. Okay, so we could think about that as the given is B. So if you look at the Venn diagram, it's just this. Okay, so the whole thing for B is 0.27. Okay, that's the whole thing, right? 0.12 plus 0.17, it's given already 0.27. And so what part of A, what's the probability of A given this? Well, A is only in here. So it's 0.12. So that's one way to do it, just by looking at the Venn diagram. Sometimes that helps. But the formula says it's the probability of A and B divided by the probability of the given, the probability of B. So the formula guides you. What's the probability of A and B? Well, there it is, 0.12. What's the probability of B? Well, 0.27. 0.27. and I think that comes out to be approximately 0.44. I think the 4 repeats. Okay, moving on. What's the probability of B given A? So what's the probability of B given A? Well, again, that's the probability of both A and B divided by, this time, the probability of A. So the probability of both is 0.12, and the probability of A was given 0.034. And so that comes out to be 0.353, something like that. Okay, now test for disjoint. Well, the probability of A and B equals 0.12, which is not equal to 0. So therefore, they are not disjoint. Now, some people just said that it's, there's overlap or something. It's best to provide the number. Okay, don't just say they're not. It's not equal to 0. Provide the number. Prove it. Okay, so conditional probability. Well, let's just take this one right here. Probability of A given B. If we use the probability of A given B, and we're going to ask, is that equal to the probability of A? So the probability of A given B is already right here. We just did it. 0.44. And we want to know, is that equal to probability of A, which was 0.34. That was given to us. I don't have to, if I'm clever, I don't have to redo any calculations. So that's not true. Okay, so if it's not true, therefore A and B are not independent. Okay, I'm going to stop here because this video is getting long. I'm going to stop here and then come back and do a part 2 for the second page.